So depending on which title you've seen, I've changed it over the course of the day. You're either here to see a talk about fleet trackers, about serverless Twilio, about the Internet of Things, or about sync. There will be all four, I promise you. My name's Andres Tak. I'm the product lead of the Twilio Sync team. This is Miaoxi Cheng. He's one of our senior developers. And what we're going to do is we're going to talk about this. This talk will actually be very heavily IoT. That's probably the #1 theme. And particularly, we're going to talk about a new feature that we've added to Sync to help support that better. But I'm not sure how many of you know Sync. Not all Twilio customers are super familiar. So let's do a review of what that is. We call Sync a purpose-built API for state synchronization. Now, what is state synchronization? This is at the core of what Sync does. State synchronization is multiple machines looking at the same bit of information, and when it changes on one machine, the other ones find out about it. The information can be whatever you want it to be. It's yours to form, it's simple JSON. This is the core of what Sync does, is state synchronization among things. And what we've done is we've scaled that up to multiple devices. We've added support for mobiles, so we support iOS, Android, we support all the major web browsers. And because we actually persist that state in the cloud, we can do clever things like connection recovery. If you miss a state transition, that's fine. Whenever you get a connection again, we'll catch you up. So, purpose-built API for state synchronization. This has been released publicly since about May. May is when we went from our developer preview into our public beta. Since then, we've seen people using Sync for a number of things that get back to core Twilio use cases. We see people using Sync for live dashboarding. Sync makes an excellent pair with TaskRouter in particular, so you can project live health indicators about your data center to the web browser or to the mobiles. We've also seen Sync used for game state management. I don't know if you've all checked out the Twilio quest that's running in the main hall. It's a really good thing. I recommend you checking it out if you have some time between this talk and the next one. It's a good way to learn in a gamified way the different little pieces of Twilio one by one and actually get solving those problems. The leaderboard, the scores that pop up, that is entirely driven by Sync. And we've seen this a couple other places as well. The other one that we like a lot is co-browsing. Co-browsing, sharing your on-screen activity with someone else. You heard from Car Finance 24/7. This is one of the core things that they do, is their sales agents can see what the customer sees and thus be more helpful to them. And I mentioned this one in particular. This one we like a lot because it reminds us why it is that Twilio has Sync. You're thinking WebSockets and live state synchronization. This doesn't seem very core to Twilio's mission, but I insist that it is. What is Twilio's mission? To fuel the future of communications. We struck the word business recently. I forgot to get rid of that. To fuel the future of communications, right? And the thing is, communications have moved on from the handheld telephone. They've moved on from video. They've moved on from just the devices that project our voices and project our images to each other. What's happened in what Sync allows, really, is that we've moved on to something that we like to call contextual communication. Contextual communication, where you use devices, you use extra data, extra information about the exchange that's happening, things that you know about your customer, things that you know about your business and what state or what relationship your customer has with that. Use these to enrich and augment the experience of communication. You have better conversations, more high bandwidth conversations, less confusion. This is why Sync belongs as part of the Twilio framework, why it is that we actually need it to power what it is that we have. So the fleet tracker, how does that fill in? This is what we're going to do today, is we're going to show you how to build a fleet tracker using Sync. Again, this is, and this gets back to that context-driven thing, because what we've had so far, we've had laptops that are connected and exchanging state. We added mobiles to that, so we actually have quite a few devices, but there's this huge category of devices missing here. These are devices that are increasingly ubiquitous, very, very state-heavy, because they participate in the world around us. And we want to have these because we want to be the next word in contextual communications, fueling the future of communications. So what we've done is we've added native Internet of Things support to Sync, which means Sync is now ready for things like home and office automation. The state of your garage door is just like the state of your call center agents. We're ready for things like scientific studies in the field, parachute a temperature sensor or a proximity sensor into the desert, measure animal, vehicle, or human movement moving around. We're also ready to directly support GPS asset tracking, which gets to the heart of what it is that we're going to do today. Now this is This, we think, is a particularly important case for sync because there's a lot of state and a lot at stake, actually, when you start talking about the location of assets of your company, whether they're vehicles, pallets of cargo, whatever it is. So that's why we're going to be building a fleet tracker with sync for IoT. It's a new feature of sync that we've added, and we're going to talk about what you're going to see. Right? What we're going to start out with is a device. It's going to be this device. Comes in a big gray box because I have fat fingers. You need lots of space. Right? And we're going to connect that to the sync cloud and then send it on the back of a bicycle with our tech lead, Andre, into the wild. Off he goes. While he's gone, it's going to be sending GPS coordinates that we're going to persist in sync. And while he's out there, we'll be looking at a web view that we've also connected to sync. Now, this is what's existed already. And those GPS coordinates, as they come in, they're going to light up dots on the map so that we can follow him around. That's what we're going to do today. We're going to connect this device to that web browser. Now, critically, as I mentioned, this part has existed already for 6 months. We've been out since May. We're in production before that. We had a long developer preview, and we've talked about this. So we're going to kind of ignore the web browser part of this for the purposes of what's important. What's really important is this connection between this IoT device and sync. And we've done two things to make this possible and make this a valid, make our offering really strong for you. First is, we have recognized, along with most of the industry, that this kind of device, these very constrained devices, you can't see it here, but this is a Multi-Tech Dragonfly. It's a very constrained environment. Can't run a JavaScript client on this, can't run Java on it, right? It's C programming in a very particular environment. And these kinds of devices that are very constrained use MQTT. It's become the de facto standard. There's other ways to do it, but MQTT is just all over the place. There's support for this in client libraries for everything, Arduinos, everything you would want. So the first thing we did to make this possible is we taught sync to represent itself over MQTT. Sync now speaks MQTT. And that's what you're going to see in some of the code that Meow shows you. The second thing that we did, if you think about what this device is, in reality, this device would be stapled to the side of a truck. It would be attached to the bottom of a shipping pallet or something. You don't have physical access to this device. The operators nor the programmers have access to this device. This needs to be manageable at a distance, and it needs to be securable at a distance. So, the other thing you'll see is the device manager, a set of tools that we've added to the Twilio console that let you secure the device, manage it, apportion it to whichever customer you want, isolate it as you need to, remove it from circulation if you need to, whatever it is. These two things are, we think, the core two ingredients that you need for sync to be viable in Internet of Things. And that's what you're going to see today. So, let's go to Meow. He's going to show you how that all works out in code.
Thank you, Andres. So before the actual demo, I would like to show you a bit about the console for our product. But since our product is still in preview mode, so you do need to sign up for it. So this is a bit.ly link. You'll be able to do a sign up. So after filling out the forms, we'll be able to give you the access. So once you get the access, you would have a icon called connected device, which is an old name for our product. Let's click that. So the first page you will see the getting started. We provide a lot of documents for you to get started with. For example, we'll give you the quick starts. We have language quick starts, including using Python for the MQTT clients. And we also have hardware examples such as ESP-based Wi-Fi chips, and Particle, which is one of our important partners, and Linkit also. So you could start from there. If you want more comprehensive documents, you could also go to the explore the documentation part. Of course, that console you need access first. So if you just want to see the documents, you could just go to our website here, the Twilio.com docs API devices. You'll be able to see the document without signing up for anything. Right, so So the first important thing I want to introduce you is the concepts in the device managers. So here I'm going to give you an example of using the recycle fleet tracking. So the most important concept here is called a fleet. So a fleet is a top unit of isolation for deployed devices. So in this case, we have two types of devices, either the trucks or either the container, the garbage bin, right? And we have also a concept called the deployment. A deployment, as you can see here, the yellow box or the green box here. A deployment is the way that we link the device resource to the sync services. So you have to have a map in between. So we use a concept called deployments. Then in order to authenticate the devices, you would need either keys or certificates. Keys is like just username and password type of authentication method, or either you can use X509 certificates. We support even ECC authenticate X509, and one more information is that we will, in a not distant future, support the trust on SIM from the Twilio wireless SIM cards. So you can just have a Twilio wireless SIM card, and you don't need to create your own new API key or other things. You can already authenticate automatically to the Twilio world. It will be there, not there yet. Okay, so that's the basic concepts for the device manager. Let's go to the console, and we'll go through what can you do with the console. So the top level resource, as we have seen, it's fleets. So you come to fleets, you have a default fleet. A default fleet is something we created for you once you sign up, and you cannot delete it. You can only reset information, but it's something as a convenience because it's unique name. So a unique name is one way to address the fleet. You can either address it with a seed or either with a unique name, and default is the unique name for the default fleet. And under the fleet, you can then browse the devices. And we already have one device created. I will tell you what's that about. And let's go to that device. Then you'll be able to manage its keys and certificates in the console. For example, click keys. You can see what's the key available for this device, or either we can go to the certificates. There's no certificates yet, but we can create one. Right. Either you can create one just on the console, or either you can paste your own X509 public key text into this console page. So that's the console part for our device manager. But since Twilio is an API company, we also provided everything in RESTful API, of course. So it's truly with this RESTful API, you can build your application at scale. So the demo we're going to show you is we built application UI demo that uses device manager, RESTful API to manage the fleets. And we use Twilio Runtime to host our backend, hence the title of the talk. It's the serverless fleet tracker. So let's go to the runtime. So we use Angular to build our front end. So we already pre-upload. We're not going to show you how to upload it. So all you need to do is click plus and all the static assets, including the front page and the JavaScript bundles. And the other information, the other one is the functions. We do have a list of functions, so we have a small unit of the backend functions. We isolate them into different functions. One of the functions I want to show you is a fleet manager, which is connecting the dots here. So we are connecting the function part with the device manager API. So we can get the device manager API with this client.preview.deploy the devices. What we are going to do is we are going to change live something in this function here. In the add vehicle, as you can see, we are creating a fleet. So this will be called by the UI. I will show you in the UI later. But here, we create a fleet with vehicle name. Create a device with a vehicle name and vehicle ID. What we're going to do here is I'm going to do awesome. All right. All right, now we updated it. Then we go to the UI. So this is the UI we deployed, the front end we deployed on the functions. Runtime assets. So we have two views here. One is a dashboard. It shows you where currently the vehicle is, and the other one is the vehicle management. So let's create a new vehicle here. Let's call it King's Vault. King's Vault. We also support actually Twilio voice just as a part of demo, so that you can call the vehicle with the driver. We'll show you later in the demo. Submit. All right, as you can see, the live change was in effect. So the name was added with awesome in the title. So what's going to show you next is that, as you can see, we already created a key here, key and secret. Maybe I need to enlarge the text. That'd be a good idea. So now we are going to live flash a hardware that's going to send the GPS coordinates to the vehicle we just created. If you come back to the dashboard view and this particular vehicle, it's empty. There's nothing there, right? So before I flash it, I just want to say that because the GPS signal, there's no signal here. So we have two units here. They're identical. A little bit more about hardware. It's actually based on multi-tag Dragonfly hardware. It has very limited amount of memory, so we cannot use other language, just C language. That's why we choose MQTT. That's one of the reasons. So we're going to flash a live unit and show on this page, but that hardware was already flashed before the talk, and Andre, our tech lead, would go outside of building and run around the London street, and we'll be able to see him. While we're waiting for him, let's flash the device. Good luck, Andre. Connection needed. USB. Yes. So we first go to the online compiler. This is the embed online compiler. And we also do some live coding here because we just generated a vehicle, literally. So here has a critical part, which is insertion of the authentication code. Okay. Yeah. So data.client ID string. I need to go back to the page here. It's called King's Vault. Copy paste. I believe it's a username. C string. The username is the key seed here. No space here. Password. All right, that's the authentication code. The other important part of the code is the data format we send to the sink through MQTT. And it's in JSON, so we have to format a string that's in JSON format. Then, since we are in this room, we don't have GPS signal, so we'll generate some synthetic ones. I'm not sure how the data is generated, but you will be able to see visually later. The next important part is the publishing code. So we need to publish our message client.publish sync. Since MQTT has a concept of topic name, but in order to map the topic name to the sync world, so we have to we come up with our conventions. Like it's called sync/lists. So we're sending the data to a sync list, and the name of the list is vehicle dash the ID here. Let's copy paste dash data. All right, then send the message. Here we go. Let's compile and see if it works. Everything looks fine. It's compiled, and a binary is downloaded locally. Before I flash hardware, I will show you in the UI code how the dot is connected. So in the UI, we will subscribe to this vehicle dash the ID of the vehicle dash data. So we'll subscribe to a sync list, and when whatever data is there, we'll visualize on the UI. And we also listen to the new item added events. So whenever there's new data coming out from this hardware, there will be a UI representation there. So let's flash hardware. So this is a binary. It's around 280 bytes. We drag it to the hardware virtual device. All right, something funny is going on. OK, now it's working. Something is happening here. The LED is flashing. It's good. OK, now we go back. Let's boot the device. Come back to the UI. Let's see. Oh, yeah, now we see something happening. So we're sending some synthetic GPS coordinates. Yes. All right. Usually you can figure out what kind of signal will be that. Success. Now let's see if Andre is back online already. Oh yeah, is he? Yeah, he's walking. All right. Let's call him. See what's going on. Do you have audio? Oh no, we don't have audio. Hang on a minute. Andre, if you hear me, wait a little minute. We don't hear you. How do I switch audio here? Internal speaker, if that's working. Where's the speaker?
We have audio somewhere. This one.
OK. I switch to the. Don't worry, we will hear him. Andre is very confused at the moment, I guess. Let's call him again. Perfect. I don't know why Andre is not moving. Hope he's not in trouble. Just in case, I'll refresh the page. Oh, yeah. OK. I think that was an internet issue. So he's apparently moving a lot, so must be very anxious waiting for us. That's very good.
Operator.
Hello, Andre. How are you doing?
Hi, Meow. I'm fine. I'm pedaling my bike through the streets of London.
I
The
see you
weather
are
is
near.
very awful.
Oh yeah, the weather is awful. It's okay. Expected. So you are near the Dufferin Street, isn't it? Yeah. So you know that I remember that on the Czech Street. So you just go front, turn left. There will be a very nice bar. Could you bring us some beer, please?
Bring us some beer.
Yes.
Absolutely.
Yes. Go straight and turn left, please.
I'm going straight
Yeah, we
and
can
turning
see,
left.
we can
I'm going
see,
to make
so-
that turn about now. I'm not sure if I see a pub here, but I'll make sure they have some beer.
Okay. Yeah. Just grab whatever. We're waiting for you.
Turning left.
All right. See you.
All right, cool. See you in a moment.
Yeah. Bye. That's success. So what we have shown you here is just a limited subset of what we have built. And to show you what's more, let me get back to Andres.
So that worked out well. So like I said at the beginning, we promised you 4 things. Internet of Things, serverless, sync, and the other thing that I forgot about. But I'm sure you saw it all. As Meow said, right? What you saw there, this was us using, you have the console if you want to inspect things manually. The console is there for debugging. The console is there for understanding what it is that you're putting together while you're developing. Once you get to scale, tens of thousands of devices, hundreds of thousands of devices, all of the same things available by a REST API. And that's what that fleet tracker was all about, is using the REST API to make this possible. As Meow mentioned, Twilio Wireless, we're going to work neatly with that. So if your device has a Twilio SIM card inside of it, the certificate on that Twilio SIM card will be useful to identify the device. And you can use the out-of-band, the SIM management tools to replace the certificate over a secure channel. This, we think, is a pretty big deal. We're looking forward to Sync becoming the new platform where you build your IoT solutions. And again, it's part of communication. These devices are highly contextual. They're out in the world with us, participating with us in our daily lives. They're aware of our positions. We're wearing them, perhaps. And with the combination of MQTT and the device manager that we have, all of that becomes possible. We're in dev preview. So hit up this link on Bitly and sign up if you have any interest in trying it. We'll onboard you as soon as we can, as we spin up the service and grow and fix things as we go. We're deeply looking forward to your feedback as well. Thanks for coming today. We really appreciate it.